Right, beta. In the last video, we have discussed about what types of pi bonded system. Isolated pi bonded system, conjugative pi bonded system. The last one is what? Cumulative pi bonded system. In resonance. One more time. What is resonance? Resonance is simply the delocalization of pi or non-bonding electrons. First point is what here? Pi bonded non-bonding electrons between adjacent orbitals. Between adjacent orbitals. What does it mean? For example, if you imagine here three carbon atoms, whatever, maybe carbon, oxygen, nitrogen, whatever. So here one orbital is there, this one lobe is there, here also one lobe is there, orbital, here also one lobe is there, orbital. There are three orbitals total. Among three atoms, maybe carbon, nitrogen, oxygen, sulfur, whatever. So right now among three adjacent. Now for example, you must focus on the middle one. This is the short trick actually. You must focus on the middle one. For example, middle one is having what here? Electron deficient site. Any electron deficient site, which means positive or radical or whatever. So then immediately the adjacent here and here, it should be electron rich. It should be electron rich, maybe LP negative, whatever. It should be also electron rich. Now the delocalization is occurred here in between adjacent. For example, this rich can donate LP to this orbital, which means the bond is formed between these two orbitals, or else now here this rich can donate LP to this middle empty orbital or less what electron density orbital, which means here simply either here delocalization is occurred or here this is what here delocalization, which means this positive orbital may be overlapped with this orbital or that orbital. So adjacent orbital, it is migrated like this, adjacent orbital. So this is called what here? Delocalization. Maybe if it is positive charge, if you take here negative charge like LP, this is what beta? Electron rich. Middle orbital is having what? Electron rich. Now it should be any electron deficient orbital. It should be also any electron deficient orbital. Now it can donate LP, which means it may be overlapped with this orbital to form certain kind of bond, that is pi bond, or it may be overlapped with the right side orbital to get pi bonded system like this. So that is what here delocalization. Delocalization is nothing but what here? One electron density or one orbital may be overlapped with right side orbital or left side atom orbital. This is what here? Delocalization. This delocalization of pi bonded or non-bonding electron is simply said to be what here? Resonance. Is it clear, beta? This is called what? Resonance. So what is the condition? What is the condition to show resonance? What is the condition? Conditions are very important. If you have to choose this one, whether this condition is satisfied or not. If it is satisfied only, then the given molecule is showing what? Resonance. So now what is the first condition? Major condition is what? First condition, the system should be conjugative. The system should be conjugative. It is not pi, not only pi, any system, positive, negative, but it should be conjugative. So how to find this conjugative system? How to find this conjugative system? I will give one tricky point, so you may be able to find that whether it is conjugative or not, right? So my point is here, one atom, maybe carbon, nitrogen or oxygen, whatever. So if it is richer carbon, richer, I am taking the carbons. If it is richer atom, then adjacent should be deficient. Then again adjacent should be rich. Then again adjacent should be deficient. If you are getting this kind of arrangement in a given organic system, that area is called what here? Conjugative area. This area is what, beta? Conjugative. It may be LP conjugative or positive conjugative or pi bonded conjugative. Overall, this is conjugative system. Later in the last class, what we have discussed about what here? Pi bonded conjugative system. Only pi bonds. Pi, single, pi, single, pi, single. That is a pi bonded conjugative system. But this is the overall conjugative system. Rich, deficient, rich, deficient, rich, deficient. This is a short trick. Now in a given molecule, how to find this substance? Whether the carbon or whether the atom is rich or deficient. How to find? Let's see. Again, I will give few more tricks here. For example, if we take a methane, next one is a methyl carbanion, the last one is methyl carbocation. Okay, beta. Methane, methyl carbanion, methyl carbocation. So methane, 8 electrons. There are 8 electrons with 4 sigma bonds. All are sigma bonds. So this molecule is what here? Electron sufficient molecule. There is no excess electron, there is no deficient electron, it is what sufficient. So this carbon is not required in the delocalization part. In the resonance part, this carbon is not required. Not only carbon, which means here 8 electrons with 4 sigma bonds. 8 electrons with 4 sigma bonds. This is what simply octet condition. Of course, octet, some more octet molecules are there, maybe showing what delocalization. That's why, what is the short trick here? 8 electrons octet with sigma bonds. Octet with sigma bonds, which means one more important atom is there. That atom maybe carbon is here. Next it is having like nitrogen NH, NH and positive charge. Now look at this one. So positive charge is it deficient? No, it is not deficient. We have to check it here. How many electrons are there around this nitrogen? 1, 2, 3, 4 bonds. 8 electrons with 4 sigma bonds. 8 electrons with 4 sigma bonds. Though this is what here? Sufficient atom. This is what here? Sufficient atom. So it is not, it should not be participated in the delocalization. So it is not deficient here. Positive sign is not indicating your deficient. It is what here? 8 electrons with 4 sigma bonds. So we should not select this nitrogen, not carbon. Carbon may or may not be, that is depending upon the carbon cloud. But here nitrogen should not be participated in the delocalization because it is sufficient only. Next one. Of course, here also CH3 minus means here how many electrons beta? 8 electrons. Electrons are what? 8 electrons. Octet condition is there. Lewis octet condition is there. But here LP are negative charge. So this may act as what here? Electron rich, carbonium. Not only carbonium, anything octet with either LP or negative charge. Here I have taken what here? Negative charge. Sometimes LP would come, that we will see. Overall 8 electrons in its valency along with LP or negative charge can act as what? Richer atom. Electron richer atom. Next one here what? Inoctate. All the inoctate. Maybe 6 electrons in the valency or 7 electrons in the valency. That may act as what here? Deficient. That may act as what here? Electron deficient. This is a sharp node. Is it clear, beta? 8 electrons with 4 sigma bonds. Of course, it is sufficient. It should not be participated in the conjugative system. Next one is what? 8 electrons with LP or negative charge. Electron richer. It is richer. Next, inoctate. Maybe 6 electrons or 7 electrons. 7 electrons, which means here you may take radical. You may take radical here. Methyl radical is there. So overall there are 3 sigma bonds along with 1 unpaired electron. So of course it is having how many? 7 total electron. That's why it is also inoctate electron deficient. Radical carbocations. Inoctate conditions are what here? Not only these two, any inoctate conditions can act as what here? Deficient. Now rich deficient here. This is what sufficient. Now in the pi bonded system, how to find richer or deficient, right? So first one is what? Non-polar. If you take non-polar bond, so non-polar depending upon other atom it may act. Depending upon other atom it may act what? Rich or deficient. What does it mean? For example, this is C, double bond C is there. Here what beta? OH is there. OH is nothing but OH is having oxygen. Check it beta. Oxygen how many electrons? 2 LPs 4 electrons. 2 BPs what? 4 electrons. 8 electrons with LP. It can act as what? Rich. If it is richer, then this pi bonded here adjacent it may act as what? Deficient. Then adjacent it may act as what? Rich. Okay, which means that pi bonded electronic cloud is delocalized towards left side carbon. So now see, this is the pi bonded system. Non-polar is there. It is in the influence of other atom. You have to decide whether it is rich or deficient. Rich or deficient. One more example here. C double bond C with C plus is there. C plus is nothing but it is inoctate condition. Inoctate means what is that beta? Electron deficient, right? You can fix it here. This one is electron deficient. Then immediately adjacent should be this pi bonded non-polar pi bonded system. It may act as what here? Now this is what here? Rich. This is what here? Deficient. So in the influence of that other atoms, this non-polar pi bonded can act. Maybe like it is what? electron rich or electron deficient. In this condition, adjacent atom can act as electron deficient. In this atom, adjacent atom can act as what? Electron rich, which means a delocalization towards that middle carbon. So like this we have to find. See this. Check it once. Is it clear, beta? Concept. One more system is there. Pi bonded system. Pi bonded, if you take non-polar pi bonded system. Polar pi bonded system, that is very easy. Polar pi bonded system. So depending upon the En difference, you can find whether it is electron deficient or electron rich substance. Right? For example, here C, R, C, double bond O, keto or aldosite is there. Now here En difference, due to En difference, what is that? Pi bonded BP is delocalized towards oxygen. So what is the charge of carbon? So carbon is what here in octet condition, it can act as deficient site. It can act as what? Deficient site. And if you take here nitro, N double bond O and coordination covalent bond with oxygen atom. Here also En difference, which is more electronegative element? Oxygen is more electronegative element. So nitrogen is getting, what is the side beta here? Nitrogen is electron deficient. Nitrogen is electron deficient. Then adjacent should be what here? This carbon, whatever the first carbon which is directly connected to nitrogen should have electron rich. So this is electron rich. Now here also it is deficient, means it should be electron rich. It should be electron rich. Now if you observe certain kind of things like this, then it is called what here? Conjugative system. First condition is satisfied. First condition is satisfied. Check it beta one more time. So RD, 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 deficient rich, deficient rich. 8 electrons with 4 sigma bonds. 8 electrons with 4 sigma bonds. This is very important. If 4 sigma bonds are there, it is not valid in the delocalization. Next, 8 electrons with LPR negative charge, rich, inoctet, deficient. So pi bonded system, two systems are there. Polar or non-polar. Polar and non-polar. Check it one more time here. Is it clear? Hope it is clear. Conjugative system, first condition, simple trick. Second condition is what? What is the second condition? Second condition is what? That area, conjugative area. Okay, not complete structure. No need to maintain the complete structure. But that conjugative area, whatever the area which is participated in the delocalization, must be coplanar. Must be what? Coplanar. So that coplanar, which means, simple trick here also same thing. Coplanar. So I may give you one tricky point. Which orbital is participated in the delocalization? So here actually sp2 hybridization would be there. sp2 hybridization would be there, which means one s orbital, one px, one py, 3 orbitals are getting overlapped to give 3 equal energy levels of sp2 hybrid orbitals. Remaining lobe is what here? Pz is a free lobe. Pz is a free lobe, right? For example, here C plus is there. Next one is what? C double bond C is there. Of course, it is having how many bonds? 3 bonds around it, which means it is what? sp2 hybridization. So one free lobe is there. This is the empty orbital, free lobe. Next one here also sp2 hybridization. So it is planar geometry. Here also sp2 hybridization. It is also having planar geometry, which means remaining lobe is what here? Pz. Here also Pz. Now this is Pz. This one is Pz. This one is also Pz. So of course here this is the representation is what beta here? Pi bond is formed between Pz partial due to partial overlappation. So pi bond is formed. Next adjacent is what here? Empty orbital. That is also Pz. Empty orbital. Maybe now if it is delocalized, this is getting what? More electron density, that is Lp. This is empty orbital. Now this may be migrated, which means that middle Lp orbital may be overlapped with right side orbital. Next, left side orbital. That is what here? Delocalization. This is what here? Delocalization. So delocalization condition is what here? The conjugative system. The conjugative system should be in coplanar. Means it is not about atoms. It is not about atoms. It is about what here? Orbitals. Z orbital. Pz, Pz, Pz. One more here atom which is having free Pz. One more here it is having free Pz. Next one is also free Pz. Then here to there, here to there, which means here it is getting overlap. This atom here it is getting like this overlappation. Next this is getting like this. So that is what here very fast. If it is in the coplanar, delocalization is very fast. That's why here to show what resonance, That conjugative system should have what? Coplanar. That coplanar is about what here? Orbitals. Actually inside, so that is concept is what here? Orbital overlappation. So coplanar should be there of which one? Orbitals, not atoms actually. Orbital coplanarity. This is the second condition. Is it clear? Conjugative area, orbital coplanarity. Orbital coplanarity, right? This is what? Second condition, conjugative area coplanarity. Third condition is very important. Third condition is very important. So that conjugative area, whatever the conjugative area, atom should have sp2 hybridization. sp2 hybridization, not sp3. Why not sp3? Given already point, delocalization of orbital. So which means there should be one free orbital. If you take here sp3 hybridization, now how it is migrated here and there. So hybrid orbitals will never be migrated. Hybrid orbitals will never be delocalized. Okay, so this is not possible. Then where is the free lobe to get overlapped here and there? That's why sp3 is not possible. We should get what here? sp2 hybridization. What is happening here? One important point to find the hybridization. One example here, CH3, CH2 minus is there. CH2 minus is there. Of course, it is a neutral atom. So 4 sigma bonds are there. Normally, you can find here what is the hybridization beta? sp3, right? Second one is also 4 sigma bonds are there. sp3. Third one is also 3 sigma bonds with 1 LP, like Vesper diagram, 1 LP and 3 bond pairs, what? Pyramidal shape. Of course, it is also having sp3. This is clear, right? All the atoms are having sp3. That is okay. Next molecule, if you have like this CH2 double bond CH, this is same CH2 pi bond. Now, of course, so here you may say, sir, around this carbon there are 3 sigma bonds, which means sp2 hybridization, sir. Yes, it's sp2 hybridization. Clear. Now, this is also having what is the hybridization beta? sp2. Because around that carbon 3 sigma bonds, 1 pi bond. That 1 pi bond is what here? That 1 pi bond is what here? pz pi bond. Here also what? pz pi bond. So that pi bond is what? pz because px py is participated. Remaining free lobe is what here? pz partial overlappation, like this. Partial overlappation pz. Is it clear? Now, here normal condition, what you think here? So around this carbon there are 3 sigma bonds, 1 LP. So it's like Vesper diagram, like ammonia. So here also what is the expected hybridization? What is the expected hybridization beta? sp3. Am I right? sp3. But this is wrong. This is absolutely wrong. This is absolutely wrong. So what is the practical hybridization of that carbon? It is having what here? It is having what beta? sp2 hybridization. Why sp2 hybridization? This is 8 electrons with LP. This carbon is 8 electrons with LP. Here adjacent we have what here? Non-polar bonds are there. So it is the influence what atom. Now it is LP. What it is? It is what here? Rich. It should be rich. One is fixed. If it is richer, then adjacent in between this non-polar. So one may act as deficient, one may act as what? Rich. Yes. RDR, rich, deficient, rich. Now it is having what? This system is having what here? Conjugative system. So resonance is possible here. Conjugative system, resonance is possible. So during this resonance, why not sp3 is participated, sir? Why not? Because here sp3 normally you make it. What is the hybridization beta? What is the hybridization? 1 s pair of electron is there, and 3 like unpaired electron which are present in p orbital. So you make it here 1 LP 3 sigma bonds, means here this is the hybridization, right? Am I right? This is the hybridization sp3, but it is wrong because this carbon is participated in the delocalization. So hybrid orbital will never be delocalized. So what is happening here? So here it requires certain amount of energy to migrate, to shift that one s electron from s orbital to s orbital to pz, s orbital to pz, s orbital to pz. Now the expect here, expect guess better here. How many sigma bonds are on this one? 3 sigma bonds. So 1, 2, 3. Yes, it is sp2 atom because we need one free orbital. Yes, it is having free orbital. This is having free orbital. It is having free orbital, which means that is what here? Pz. These two are also pz. So you may get like this arrangement. Now all the pz, 3 free orbitals are in coplanar. Now migration is possible, delocalization is possible from here to there, here to here, here to there, here to here, like this. Now this condition is very important, right? That's why atom should have sp2, which means one free lobe should be there. One free lobe should be there. So this is the third condition. Second beta, is it clear? This is the third condition, which means what is the short note here? If you observe any atom which is participated in the delocalization, then it should have sp2 hybridization. The atom which is participated in the resonance, should have what here? sp2. Which is participated in the resonance should have what beta here? sp2. So this hybridization condition is very important. sp2. So what are the other examples? This one is what here? C minus. Normally you may expect sp3, but due to this delocalization it may become what here? sp2 because of this arrangement. Resonance requires free lobe, not hybrid lobe. That is the condition. See now, CCNH2 is there, CCNH2 is there, NH2, focus on NH2, C double bond CNH2 is there. Now the first condition is what beta? First condition is normally 3 sigma bonds 1 sp3. Yes, 3pr, 3 sigma bonds 1 lp. What is the hybridization? sp3. Yes, it is clear. Second one, so here non-polar bond is there in the influence of this NLP. Now here you may get what? Resonance, because it is a richer means you may get here deficient, you may get here what? Rich, which means delocalization towards this. Now this orbital is participated in the delocalization, which means it should be free. Right? Now what is the hybridization of nitrogen? sp2. What is the hybridization of nitrogen? sp2, not sp3. The same manner with oxygen. CC, ethyl alcohol. If you take here ethyl alcohol, next one is vinyl alcohol, ethyl alcohol and vinyl alcohol. Normally you may observe here two LPs on each oxygen atom, 2 LPs and 2 BP. This is like Vesper. sp3 with the 2 LP effect is what? Bell shape. So whatever the shape it is. Now what is the expectation here? Nothing is there because it is sufficient. 8 electron sigma bonds sufficient. So you may not get what? Rich deficient order like this. So that's why there is no resonance is observed here. So what is the hybridization? Expected hybridization sp3. Is it clear beta? sp3. But the second one here, maybe it can act as what here? Rich, because 8 electrons with lp. If it is richer, adjacent may become what? Deficient, because in the influence of other atom it may shift like this. Now it should be what here? Rich, right? Now it is participated in the delocalization. Then expect. What is the hybridization of oxygen atom? What will be the hybridization of oxygen atom? Yes, absolutely correct. What is that? sp2. What is it beta? sp2. In the same way, here nitrogen is there. Nitrogen atom in cyclic, double bond. Nitrogen, oxygen atom in cyclic, double bond. Right? Now here also, nitrogen is normally having 3 bonds, 3 sigma bonds with 1 LP, but that LP is the migrating what? It is a probability of finding what your resonating contributor, means it is participated in the resonance. That's why what is the hybridization of this one? sp2. This here there are 2 LPs. 2 lone pairs are present. One of the lone pair is participated in the delocalization because it is already rich electron density. Adjacent deficient condition is there. Adjacent here also deficient condition is there, which means here it may participate in what? Delocalization. That's why what is the hybridization of oxygen atom? What is the hybridization of oxygen atom? sp2. So these three conditions should be satisfied. These three conditions. Clear beta? Check it. First thing is what here? Conjugative system. Conjugative system not only about pi bonded, like these factors you have to choose. These are the short notes. Okay. If you understood this one, it will be very easy to find resonating contributors, that we will discuss later. Okay, first condition is what? Conjugative system. Second condition, that conjugative area, whatever the area which is participated in the delocalization, should be in what? Coplanar, which means it is not about actually atoms, it's about what? Orbitals. The free orbital should be in planarity. Maybe it is what here? Not linear. Here one orbital is there, maybe next orbital is here is there, next orbital is like this, no problem, but all should be in coplanar. Next, it may be like this migrated, it may be like this overlap, like this, everywhere. So what is that? It should be planar, not linear. No need to maintain linear condition. Planarity. Now the delocalization of that non-bonding or pi bonding electrons are very fast, very easy. That's why this condition should be satisfied. Third condition, atom should have sp2, same condition, which means here one free log should be there. That's why here the atom should have sp2, remaining that orbital is free orbital. So if you observe these three conditions, then that the molecule may show resonance. It may show resonance or delocalization. So this is the condition. First one, second one, third one. Careful beta. First one, second one, third one. Check it clearly.